Good day, everyone. We are the group 3, and now we're going to discuss the lesson 7, all about the environmental geology and earth resources. The learning outcomes of these lessons are: first is to describe the layers of the earth. Number 2, to explain how tectonic processes reshape the earth. Number 3, to report about the rock cycle by describing how igneous rocks, metamorphic rocks, and sedimentary rocks are formed. Number 4, differentiate between mechanical weathering and chemical weathering. And lastly, to identify the metal and non-metal resources.
Earth processes shape our resources. Convention in the mantle causes tectonic plate movement, earthquakes, and volcanoes. When oceanic continental plates collide, the lighter continental plate rides up, forming mountains. The oceanic plate subsides, forming trenches. The volcanic ring of fire results from these plate collisions. All of us benefit from Earth's geological resources right now are undoubtedly using products made from these resources. Plastic of many types are made from petroleum, iron, copper, and aluminum. Mines produce the materials for the electrical wiring that brings you power there. Earth metals are essential in your cell phone and your computer. All of us also share responsibility for environmental and social devastation that often results from mining, drilling, and processing materials.
So good day. For this video, I will be discussing the Earth is a dynamic planet. The Earth is a layered sphere, and the core or interior is composed of a dense, intensely hot mass of metal, mostly iron, thousands of kilometers in diameter. Solid in the center but move fluid in the outer core. So this immense mass generate the magnetic field that involves the Earth. Surrounding the molten outer core is a hot, pliable layer of rock called the mantle. So the mantle is much less dense than the core because it contains a high concentration of lighter elements such as oxygen, silicon, and magnesium. So the earth layered structure comprises a solid inner core and a liquid outer core, primarily composed of iron and nickel. So the outer core motion generates Earth's magnetic field. It is vital for protecting our atmosphere. Surrounding the core is a mantle, a pliable layer of rock rich in silicate minerals, driving plate tectonics through mantle convection. Plate tectonic shape our planet's surface and influence geological phenomena like earthquakes and volcanoes. Understanding these layers is crucial for predicting natural hazards, studying climate patterns, and managing earth resources sustainability. So, the outermost layer of the earth is a cool, lightweight, brittle rock, what we call crust. The crust below ocean is relatively thin. It is 8 to 15 kilometer dense and young, and then less than 200 million years old because of the constant recycling, while crust under continents is relatively thick. It is 25 to 75 kilometer and light and has an old as 3.8 billion years, with new material being added continually. It is also predominant predominantly granitic, whereas oceanic crust is mainly dense basilitic rock. So, the Earth crust comprising oceanic and continental crust exhibits stark differences in thickness, density, and age. Oceanic crust originating from mid-ocean ridge and undergoing recycling at subduction zone is characterized by its thinness, high density, and youthful age, primarily composed of basaltic rock rich in iron and magnesium. Conversely, continental crust, predominantly consisting of granite, manifest as a thicker, less dense, and considerably older layer with ages spanning up to 3.8 billion years. Unlike oceanic crust, continental crust undergoes growth over time through volcanic activity, sedimentation, and tectonic processes. It is contributing to its resilience against subduction. This distinction is in crustal composition and behavior shape various geological features, including the emergence of continents, formation of mountains, ranges, and creation of ocean basins. Furthermore, they play a pivotal role in influencing climate patterns, shaping landscapes and determining the distribution of life on Earth. Understanding the dynamic interplay between oceanic and continental crusts provide crucial insights into the planet's geological history, evolutionary processes, and the intricate dynamics operating within its layer. That's all. Thank you.
So, let's move on to the next topic, which is the tectonic processes reshape continents and causes earthquakes. So, the huge convection currents in the mantle are thought to break the overlying crust into a mosaic of huge blocks called tectonic plates. These plates slide slowly across the Earth's surface like wind-driven ice walls on water, and some places breaking up into smaller pieces, and in other places it crashes ponderously into each other to create a new, larger and masses. Ocean basins form where continents crack and pull apart. So magma, or known as the molten rock, forced up through the cracks forms new oceanic crust that piles up under water in mid-ocean ridge. So magma is mostly it comes from the volcano or the molten rock. So creating the largest mountain ranges in the world, these ridges wind around the Earth for about 74,000 kilometers or 46,000 miles. Although concealed from our view, this jagged range boasts higher peaks, deeper canyons, and deep sheer cliffs than any continental mountains. So slowly spreading from these fracture zones, ocean plates push against continental plates. So earthquakes are caused by jerking plates grind past each other, and mountain ranges like those on the west coast of North and South America are pushed up at the margins of colliding continental plates. So, earthquakes are caused by jerking plates. So, the two plates grind with each other o naana siya sa ilalom sa ato ang surface. So, naay tendency nga if mag-grind na sila ang duha ka plates mag-cause na siya og earthquake or movements sa ato ang surface. And also, naapod siya tendency nga mo result of formation of mountains because the two plates grind with each other, and the Himalayas are still rising as the Indian subcontinents that collides inexorably with Asia. So, the Southern California is sailing very slowly north toward Alaska. So, in about 30 million years, Los Angeles will pass San Francisco if both still exist by then. And now I will show you a diagram or the map of tectonic plates. So this map is the plate boundaries that are dynamic zones. This is characterized by earthquakes, volcanism, and the formation of great reefs and mountain ranges, or known as the shaded areas. So, the arrows nag-indicate ni siya sa direction of subduction, where one plate is diving beneath another. So, ganyan na siya. Muna siya makita diri ang arrows, where is the direction of the subduction. So, that is the subduction, that the one plate is diving beneath another. So these zones are the sites of deep trenches in the ocean floor, and it has a high level of seismic and volcanic activity. So when an oceanic plate collides with a continental landmass, the continental plate usually rides up over the seafloor, while the oceanic plate is subducted or pushed down into the mantle, where it melts and rises back to the surface as magma. So and also, deep ocean trenches mark these subduction zones, and volcanoes form where the magma erupts through vents and fissures in the overlying crust. So trenches and volcanic mountains ring in the Pacific Ocean rim from Indonesia to Japan to Alaska and down to the west coast of the Americas, forming a so-called ring of fire, where oceanic plates are being subducted under the continental plates. This rising is the source of more earthquakes and volcanic activity than any other region of the Earth. So over millions of years, continents can drift long distances. Antarctica and Australia once were connected to Africa. For instance, some were near the equator and supported luxuriant forests. So geology suggests that several times in the Earth's history, or most or all of the continents have gathered to form supercontinents which have broken and up and reformed over hundreds of millions of years. So the distribution of continents has profound effects on the Earth's climate and may help maintain in periodic mass extinctions of organisms, marking the divisions between major geologic periods. So humans have now become a major geological force. We may move more dirt and rock, cause more species extinction year than any natural forces. Some geologists call this era the Anthropocene after its important driving force us. So this is a Pangaea, an ancient supercontinent of 200 million years ago. It is combined of all the world's continents in a single landmass. The continents have combined and separated repeatedly. And this is also the period and eras in geological time and major life forms that mark some periods. Some authors claim that we've now entered a new era, which is the Anthropocene, or dominated by humans.
Everyone, my name is Vigaliza Idoman. Today I will discuss minerals and rocks. A mineral has a specific chemical composition and crystal structure. The three rock types, igneous, metamorphic, and sedimentary, constantly reform into each other. Metals are valuable because they are strong and easily shaped. A mineral is a natural occurring inorganic solid with a specific chemical composition and a specific internal crystal structure. A mineral is solid. Therefore, ice is a mineral with a distinct composition and crystal structure, but liquid water is not. Similarly, molten lava is not crystalline, although it generally hardens to create distinct minerals. Metals such as iron, copper, aluminum, and gold come from mineral ores. A rock is a solid cohesive aggregate of one or more minerals. Within the rock, individually mineral crystals, or grains, are mixed together and held firmly in a solid mass. The grains may be large or small depending on how the rock was formed, but each grain retains its own unique mineral qualities. Each rock type has a characteristic mixture of minerals, grain size, and ways in which the grains are mixed and held together. Granite, for example, is a mixture of quartz, feldspar, and mica crystals. Rocks with a granite-like mineral content but much finer crystals are called rhyolite. Chemically similar rocks with large crystals are called pegmatite.
So, good day everyone. My name is Jabis Clive M. Gonzalez, and my topic is the rock cycle creates and recycle rock. So, um, although rocks appear hard and permanent, they are part of relentless cycle of formation and destruction. They are crushed, folded, melted, and recrystallized over time by a dynamic process related to those that shape the large-scale features of the Earth's crust. So we call this cycle of creation, destruction, and metamorphosis the rock cycle. The rock cycle. Understanding something of how this cycle works help explain the origin and characteristics of different types of rocks. In a simpler terms, the rock cycle describes how the three main rock types that compose the Earth's lithosphere are constantly transformed into one another through geological process. These three rocks types, which we will learn about in more detail in the following chapters, are igneous, sedimentary, and metamorphic rock. So there are three major rock classification: the igneous and metamorphic and sedimentary. So first is the igneous rock. From igni, the Latin word for fire, so are solidified form, hot, molten, and magma or lava. Most rock in the Earth's crust is igneous. Magma extruded to the surface from volcanic vents cools quickly to make finely crystalline rocks such as basalt, rhyolite, or andesite. Magma that cools slowly into surface chambers or in the intruded between overlaying layers makes coarsely crystalline rocks such as gabu, rich in iron and silica, or granite, rich in aluminum and silica, depending on the chemical composition of the magma. So, igneous rocks, in a simpler terms, from the Latin word for fire, so form when hot molten rocks crystallize and solidifies. So the melt originates deep within the earth near active plate boundaries or hot spot, then rises toward the surface. So metamorphic rock, from the melting, contorting, and recrystallizing of other rocks deep in the ground, tectonic forces squeeze, fold, heat, and transform solid rock. Under this condition, chemical reaction can alter both the composition and structure of the component minerals. So metamorphic rock are classified by their chemical composition and by the degree of recrystallization. Some minerals form only under extreme pressure and heat. Diamonds or jade, for example, other more moderate condition, graphite or talc. Some common metamorphic rock or marble from limestone, quartzite from sandstone and slate, from mudstone and shale. Metamorphic rock often have beautiful color and patterns left by the twisting and folding that creates them. So, in a simpler terms, metamorphic rocks started out as some other type of rock, but have been substantially changed from their original igneous, sedimentary, or earlier metamorphic form. So, metamorphic rocks from when rocks are subjected to high heat, so high pressure, hot mineral rich fluids, or more commonly, some combination of these factors. So the last one, the sedimentary rock, are formed when loose grains of other rocks are consolidated by the by time and pressure. Sandstone, for example, is solidified from layer or of sand, and mudstone consists of extremely hardened and mud and clay. Tuff is formed from volcanic ash, and conglomerates are aggregates of sand and gravel. Some sedimentary rocks develop from crystals that precipitate are out of extremely salty water. Rock salt made of the mineral halite is ground up to produce ordinary table salt. Sodium chloride salt deposit often form when a body of salt water dries up, leaving salt crystal behind. Limestone is a rock composed of cemented remains of marine organisms. You can often see the shape of shells and corals in pieces of limestone. Sedimentary formation often have distinctive layers that show different condition when they were laid down. Erosion can reveal this layer and inform us of their history. So sedimentary rocks are formed from pre-existing rocks or pieces of living organism. So they form from deposit that accumulate on the earth's surface. Sedimentary rocks often have distinctive layering or bedding.
So hello everyone, my name is John Carsalva and I will be discussing the weathering and sedimentations. So most crystalline rock are extremely hard and durable, but exposure to air, water, changing temperatures, and reactive chemicals agents slowly breaks them down in a process called weathering. So most crystal rocks extremely hard and durable, gahi og pagod. But exposure to ma-expose siya sa air, water, o changing temperatures and reactive chemicals, mao ni siya hinungdan nga magkahinay-hinay o kaguba na siya nga crystalline rocks. Og mao ni siya ginatawag na siya nga weathering. So, mechanical weathering is physical breakups of rocks into smaller particles without a change in chemicals compositions of the constituent minerals. You have probably seen the results of mechanical weathering in rounded rocks in rivers or on shorelines, smoothed by constant tumbling in waves or currents. On a large scale, mountain valleys are curved by rivers and glaciers. So, mechanical weathering is a physical breakup o physical nga pagkaguba. Sa usa ka bato nga mahimo siyang gagmay nga mga particles na wala siya kabag-uhan sa iyang composition nga gabuo gyapon siya og minerals. So kung dira siya gikan sa usa ka bato, so kung magguba gyapon siya, mao ra gyapon yung minerals, pero gagmay na siya, nga particles. So you have probably seen the results of mechanical weathering in rounded rocks. So makita nato ni siya sa ang resulta sa mga makita nato ni siya nga kind of weathering sa mga nang lingin nga bato nga daplin sa mga ilog o mga kind of baybayin na kanabang gipalinis o gipagamay ni siya sa pagtuloy nga pagbundak sa balod o sa mga pag-agos sa river. On a large scale, mountains, valleys are covered by rivers and glaciers. So this is the structures of weatherings nga ng bato nga na-expose siya sa weatherings. So weatherings slowly reduce the igneous rocks to lose the sediment. So mo ni siya ang structures nga na-expose siya sa weathering nga nagkahinay siya og guba og ang
iyahang bato nagkagagmay niya particles. So chemical weathering is unselective removals or alternations of specific minerals in rocks. These alternations leads to weakening and disintegrations of rocks. So, ang chemical weathering ay piling pagtanggal o pag-usob sa usa ka particular nga mineral sa bato. Ang kabaguhan nga ingon ani nga mo abot nga ang higayon nga ang bato maguba na jud siya. And excuse me nang among the more important chemicals weathering is process of oxidations, combinations of oxygens with an elements to form an oxides or a hydroxides minerals, and hydrolysis. Hydrogens, atoms from water's molecules, combines with another chemicals to form acids. The products of these reactions are more susceptible to both mechanical weathering and dissolving in waters. So, it is an important chemicals weatherings. It is processed by oxidations. It is a kind of combinations of oxygens with an element formed by oxides or an hydroxides. So, talking about the hydrolysis, it is an hydrogen atoms from water's molecules combines with other chemicals to acids. So, this product, its reactions are more susceptible to both mechanicals, weatherings, and dissolving of waters. So, for instance, when carbonic acids form when rainwaters absorb CO2, percolates through porous limestone layers in the ground. It dissolves the rocks and creates caves. So it is kinds of examples if uncarbonic acids have formed when rainfall absorbs CO2. So percolates through porous. Usan siya sa kinds of pamamagitan sa pagbuhaghag ng usa ka limestone layer sa lupa, o mo ni siya hinungdan nga ang bato mulikha ni siya og kuweba or caves. Particles of rocks loosened by wind, water, ice, and other weathering force are carried downwind or downstreams until they come to rest again in a new location. So ang mga particles nga bato nga aba siyang luwag sa tungod sa exposure niya sa hangin, tubig o ice at uba pa nga puwersa nga uban pang puwersa sa weathering nga dinadala ng gidala siya sa ubos sa pamagitan ng hangin o agos nga madala siya sa laing nga locations. And kani siya nga disposition, these minerals are called nga sedimentations. So water, wind, and glaciers deposits particles of sands, clays, and silt far from their source. Much of the American Midwest, for instance, it's covered with hundreds of meters of sedimentary materials left by glaciers, which tell or rock debris deposits by glaciers ice, wind losses or fine dust deposits, river deposits of sands and gravel, and oceans deposits of sands, silt, clays, and limestones. So, ang tubig o hangin, mga glaciers, ay ma-deposit ni siya sa mga particles na buhangin, no, sa mga balas. So, karamihan ani dito sa American sa Midwest. Halimbawa ay matabunan ni siya sa mga matabunan ni siya og mga pila ka metro nga mga sedimentary nga materials. So, ang mga ang mga kind of mga deposito sa mga balas ay kuan kada ba mga graba nga gikan sa graba nga naa sa river, river excuse me og mga karagatan, mga deposito sa buhangin at banlik sa laad nga apog. So that's all, thank you.
So, good afternoon everyone. I'm discussing the economic geology and mineralogy. Economic mineralogy is the study of resources that are valuable for manufacturing and trade. Most economic minerals are metal ores, metals with unusual high concentration of metals. Lead, for example, generally comes from the mineral galena, and copper comes from sulfide ores such as bornite. Non-metallic geologic resources include graphite, feldspar, quartz crystals, diamonds, and other crystals that are valued for the usefulness or beauty. The Earth is unusually rich in mineral variety. Mineralogists have identified some 4,400 different mineral species, far more, we believe, than any of our neighboring planets. What what's the difference? The processes of plate tectonics and the rock cycle on this planet have gradually concentrated uncommon elements and allowed them to crystallize into new minerals. But this accounts for any about one-third of our geologic legacy. The biggest difference is life. Most of our minerals are oxides, but there was little free oxygen in the atmosphere until it was released by photosynthetic organisms, thus triggering evolution of our great variety of minerals. Metals have been so important in human affairs that major epochs of human history are commonly known by their dominant materials and the technology involved in using those materials. Stone Age, Bronze Age, Iron Age, and etc. The mining, processing, and distribution of these materials have broad implication for both our culture and our environment. Most economical valuable crustal resources exist everywhere in small amounts. The important thing is to find them concentrated in economically revo- recoverable levels.
Metals are malleable substances that are useful and valuable because they are strong, relatively light, and can be reshaped for many purposes. The availability of metals and the methods to extract and use them have determined technological developments as well as economic and political power for individuals and nations. The metals consumed in greatest quantity by world industry including iron 740 million metric tons, aluminum 40 million metric tons, manganese 22.4 million metric tons, copper and chromium 8 million metric tons each, and nickel 0.7 million metric tons. The complex worldwide network that extracts, processes, and distributes these metals has become crucial important to the economic and social stability of the nation. Primary use of some major metals. Aluminum use. Packaging, food, beverage, 38% transportation, electronics. Chromium, high-strength steel alloys. Copper, building, construction, electric and electronic industry. Iron, heavy machinery, steel production. Lead, lead gas, gasoline, car batteries, paints, ammunition. Manganese, high-strength, heat-resistant steel alloys. Nickel, chemical industry, steel alloys. Platinum group, automobile, catalytic converters, electronic metal uses. Gold, medical, aerospace, electronic use, accumulation as monetary standard. silver, phot- photography, and electronics and jewelries.
Non-metal mineral resources include gravel, clay, glass, and salts. Non-metal minerals constitute a broad class that covers resources from gemstones to sand, gravel, salts, limestones, and soils. So non-metal minerals consist of sand, gravel, salts, limestones, and soils. Sand and gravel. Production for road and building construction comprise by far the greatest volume and dollar value of all non-metal mineral resources and a far greater volume than all metal ores. Sand and gravel are used mainly in brick, concrete construction, and paving as loose road filler and of sandblasting. Sand and gravel is used for construction and bricks used to build buildings. High purity silica sand is our source of glass. These materials usually are retrieved from surface pit mines and quarries, where they were deposited by glaciers, winds, or ancient oceans. So high purity silica is a source of glass. The glass is made of silica sand. Limestone, like sand gravel, is mined and quarried for concrete and crushed for road rock. It also cut for building stone, pulverized for use as an agricultural soil additive and neutralized acidic soil, and roasted in lime kilns and cement plants to make plaster, hydrated lime, and cement. So there is example of limestone, fossiliferous limestone, Columbus limestone. These are for an agricultural soil to neutralize acidic soil. Evaporites, materials deposited by evaporation of chemical solutions, are mined for halite, gypsum, and potash. These are often found at or above 97% purity. Evaporites examples are calcite, gypsum, and anhydrite, halite, silvite, carnallite, langbeinite, polyhalite, and kyanite. Sulfur deposits are mined mainly for sulfuric acid production. In the United States, sulfuric acid use amounts to more than 200 pounds per person per year, mostly because of its use in industry, car batteries, and some medicinal products. So, sulfur is used for industry in United States for batteries and for medicinal products. Interestingly, the world's largest supply of lithium, which is essential for lightweight batteries for electric cars, cell phones, and other consumer goods, is a vast of salt flat called the Salar de Uyuni in southwestern Bolivia. The lithium, which was deposited in a huge salt lake, evaporated eons ago, could make this impoverished country the Saudi Arabia of the electronic age.
Good day, everyone. I'm going to discuss the conclusion of our topic. The Earth's surface is shaped by shifting pieces of crust, which split and collide slowly but continuously. The Earth itself is moving as its plates within moves continuously to adjust slowly, thus creating structures on the surface. Earthquakes, volcanoes, and mountains generally occur on plate margins. These are the examples of structures that form on the surface due to the shifting pieces of crust. Rocks are composed of minerals, and rocks can be described according to their origin in molten material, or igneous rocks. Eroded or deposited sediments or sedimentary rocks or materials transformed by heat and pressure deep in the earth, or metamorphic rocks. These types of rocks are found on Earth's crust. Um, Earth resources, including oil, gas, and coal, are the foundation of our economy. Earth is rich in diverse resources which we people benefit from it. Metals are expensive to extract, but they are extremely valuable because they are ductile or bendable, yet strong, and because they carry electricity. Example is copper. And build amazing structure such as tall building. Mining and refining of metals and other geologic resources can cause severe environmental damage. Mining may be
way to discover new minerals within the earth and extract them, but in return destroys the earth as it bores into the earth's crust, leaving large holes underground. In some cases, land can be restored to something close to its original state. But when you dig a mile deep hole in the ground or a loop the whole top of a mountain and dump the waste into a nearby valley, it's unlikely that the damage will ever be undone. Many materials can be recycled, saving money, energy, and environmental quality. We all know the three R's, which is the reuse, reduce, recycle, helps us conserve our environment. Recycling aluminum consumes 1/20th of the energy to extract new aluminum. For example, is recycling copper takes about 1/8 as much energy. We can also save energy and resources by replacing traditional materials with newer, more efficient ones. Fiber optic communication lines have replaced much of our copper wiring, adding speed and efficiency while saving copper use. Understanding both geologic hazards and resources is essential in environmental science. These factors influence environmental quality, resource provision, and environmental risk that affect all our lives. That's all. Thank you.
So, that would be all for the lesson 7, all about environmental geology and earth resources. Thank you for listening.